Hi and a very good day. For this video session, I will show you on how to do forecasting using Econometric in our programming. Okay, so based on your slides, we have example based on economic data. Okay, so when you can refer to economic data that I provide to you in your Telegram group. So in this economic data, we have several variables, and uh, for these particular examples, the new car registration is the dependent variables, whereby unemployment, CPI, BLR, GDP, total export, total population, and income is the independent variables. Okay, now to start models the to start building the best models, okay, to predict the new car registration based on these particular variables, first we have to make sure that there is a relevant theory between the relationship of IVs and DVs. Okay, especially the sign. Okay, it means that, as example here for unemployment and new car registration, uh, they actually have, based on theory, they have negative relationship. It means that when uh, when unemployment decrease, when unemployment decrease, the new car registration will increase. Okay, they have the reverse effect. But for positive relationship, as example here, GDP, if since that GDP have positive relationship with new car registration, it means that when GDP increase, we expect that new car registration is also increased. So you have to make sure that this theory, the sign of the relationship between IVs and the DV is first already being justified, so that when we do the model selection, we can compare the theory and the estimation sign. Okay, suppose that if when you do the estimation, you get, as example, when we do the unemployment, okay, and you get positive sign instead of negative. So it means that the the estimated coefficient is not parallel with the theory. So we can consider to drop unemployment. That's one of the things lah. Okay, so make sure that you do this, and you can justify this theory based on previous research or based on economic reporting. Uh, Economic reporting lah. Okay, so to do this example, first you have to make sure that uh, the economic data is available in your R. Okay, so like I mentioned in our class, okay, you have to make sure that the data, okay, the data here, okay, see, suppose since that I use economic data CSV, okay, so this is my directory, okay, this is my directory, okay, this is my directory, and this is my project. Okay, okay, this is my directory, and this is my project. Okay, I have the same location. Okay, STA 572 and STA 572. So I want to make sure that my economic data is in this particular directory. Okay, and uh, you can do like copy and paste the data, or you can do the setting here lah. Okay, so make sure that this data is available. And next, after you after the economic data is in your directory, you can run this particular function lah. Okay, read.csv, the data names, okay, and then you run. Okay, after you run this, okay, since that we use economic underscore data is the name, you can see this you can see this economic data is actually in your environment. Okay, this economic data is in your environment. Before you go for the next step, make sure that this particular data set is available in your R environments. Okay, and you can check the data set, and basically, okay, you can take a look at the variable name here. Okay, year, number of car registration, BLR, unemployment rate, total population, CPI, total export income, and GDP. And we can see that this particular observation is in yearly data. So this is yearly data from 1969 until 2022. So uh, now we will employ econometric modeling, and to select the best model, we will use general to specific modeling. It means that uh, for all of these particular variables that we have in our data set, we will start with all variable being included in the models. Okay, so before we do the exercise, make sure that you call the library. Okay, since that there are several functions that we will use later that is available in this particular package. So if you don't run this, okay, you can run. Okay, so I clear my console first. Okay, so you run. Okay, and you run. If your R have this particular package, it will give you this kind of message when in your console. If not, you have to install the packages. Okay, you have to install the packages. Right. So now we are ready to do the modeling. Okay. To do the models, we will use LM function. Okay, we will use LM function. Okay, and then the way we write the model is by using this tilde symbol. Okay, so this is your DVs, your dependent variables, and then this is your independent variables lah. Okay, and for this particular examples, I will use different variable names compared to your slides. Okay, because for certain variables in your economic data, there is actually okay. Let's say I call the names. Okay, I clear the console. I call the names. So as we can see here, this particular variable have quite a long variable name. Okay, what we do is we can change these particular variables. Okay, let's take a look at the original data. Okay, this is year, number of car registration, BRR, unemployment rate, and so on. Okay, so suppose that I just want to change this particular variable names. Okay, BLR, unemployment rate, and total population. Because of what? Um, if you call the variable name with a lot of or spaces uh, or long name like this, R will have a special way to treat that variable name. Okay, so that's why I want to turn this into a single variable name. As example, car underscore register. Instead of I use space, I use underscore. It means that this is only uh, one one words, one the same same word, BLR, employment population. Okay, so I use name function. I use name function towards the economic data, and this is referring to the number 2, 3, 4, and 5. Okay, so when I run this, okay, when I check again my economic data, okay, now as you can see here, as you can see here, my variable name is changed. Okay, already changed according to my specification. All right. If you feel that the easiest way, there is actually alternative lah for easiest way. Alternative is you change the original data. Okay, suppose that you have the original data. Okay, so this is your original data. Okay, before you call this particular data in R, you can simply change this. Okay, so means that you simplify the name. It is easy for us to work with if with a simple variable names compares to this one lah. Okay, but before you change, make sure that you understand. Okay, what are the variables is for, eh? Okay, so that's one things that I can suggest. Okay, but now I use name function, and I already changed my variable, my previous variable into this is the original variable names, and I have to check again what are the current names for my variables. Okay, economic data, and then I run economic data. So this is my current variable name. Okay, so based on this, I will feed this variable using LM function, and my models we will name as model 1. Okay, model 1 LM function, and this is my Y. So since that this is the name that I use, okay, uh, I can you don't have to keep typing the models. Okay, as example here, model 1. Okay, and then LM. Okay, using name function, you just copy and paste this one. Okay, copy and paste this one. Right. Unemployment. This is how I do lah. So uh, the way on how to write the LM is you have to plus everything. Okay, since that we don't estimate the sign. Okay, the sign that we will use in LM function is plus. Okay, and then you just copy and paste. Okay, or kalau if it only a short names, yes, uh, you can type lah. Okay, so you just choose whatever method that comfortable with. Okay, but since that as we can see here, this total export is not a single word, so that's why you have to put the symbol is actually okay. You have to put this you have to type this little guy here in your keyboard to show to make sure that R can read that particular variables. Okay, plus population plus income from which data. Okay, data equals to economic data. Okay, and then you can run. Okay, so when you run, we will take a look at the fitted models. Okay, you can refer to your slides on how to explain. Okay, how to explain the parameter, how to explain the output for LM function. Okay, so let's take a look at the model 1 first. Okay, so since that this is the fitted model name model 1. Okay, you take a look at the summary. Okay, the first thing that we will investigate is Okay, the first is this one. Okay, the first is the F statistic. Okay, whether the value is general fitness. Okay, the F test. Whether the p-value is less or greater than 0.05. Okay, since that this p-value is less than 0.05, uh, uh, at least one of these variable is significant. Okay, significant to explain the dependent variable. So we can proceed the next step by zooming out the t-test. Okay, this is the t-test. It means that for every independent variable, we will check whether it is significant or not. Okay, uh, so this is uh, uh, there are some variable that's significant and some variable is not significant. Okay, and the next thing that we are interested to know is this r square and also adjusted r square. Okay, so how do you explain the uh, this particular things? Okay, let's take a look at our notes. Okay, so for model 1, okay, for model 1, uh, the adjusted r square and f test are highly significant. Okay, because this r square that we get is uh, 0.9623. Okay, however, CPI and NGDP register sign in contrast to theoretical assumption. Okay, so let's take a look at uh, the CPI. Okay, CPI, based on this, it gives positive. Okay, whereby we state that CPI must have negative theoretical relationship. So that's why we say uh, it uh, it violate the sign. Okay, and then besides that, we will continue checking the VIF. Okay, so the VIF must less than 10. So this particular variables, they have VIF more than 10. It means that there is multi-collinearity problem in these particular models. And next, we take a look at the Bin-Watson test. Okay, so the Bin-Watson, we want to check whether there is serial correlation or not. Okay, to make sure that there is no serial correlation, the p-value here, okay, the p-value here for the Bin-Watson, the p-value, okay, the p-value must greater than 0.05. The p-value must greater than 0.05. Okay, okay, so for the Bin-Watson, value is significant that indicate the model has serial correlation problem. So for this particular since p-value less than 0.05, serial correlation happen kan, serial correlation exists, correlation problem exists. Okay, and for VIF there are several variables that show VIF is for multi-collinearity. Okay, VIF greater than 10, multi-collinearity problem. Okay, and what about the next test, the Broch-Pagan test? Okay, let's take a look at the Brose-Bergen test. Okay, we run this. Okay, so for Brose-Bergen test, since that the p value, since that the p value is since that the since that the p value is is greater than 0.05. Okay, p value for brush Bergen test is greater than 0.05. So the variance is constant across time. Since when is a constant across time, we say that it is a homoscedasticity. Okay. For this particular problem, the model is there is no heteroscedasticity problem in this particular model, since that the Brose-Bergen is given as the p-value greater than 0.05. Okay, the p-value. Okay, so that's the thing that we will do, and based on that we will decide, okay, which variable should be retained and which variable should be removed. Okay, so for this particular exercise, you can continue by following the slides and take a look on how this particular example uh, they choose which variables they need to remove. Okay, so basically for these models to be removed, what you can do is you don't have to keep writing the same code again and again. But what you can do is you can, as example, we want to remove income for model 4, okay? So you remove income. So since that we will drop one by one, you can copy the previous models. Okay, you can copy the previous models and you just rename it as model 4 and remove this one, remove these variables. And then you run the statistical validation again. Since that now you have a new models to as the candidate of as the candidate that uh, to a good models to predict the the car registration. Okay, so you can continue and try to do the exercise and take a look whether you are successfully reaching these particular models. Okay, since you like one car. Okay, okay, you are able to reach these particular models. Okay, and since that we uh, we can see that all of the variable is significant here, it means that the the checklist to conclude whether this is the best model or not is being fulfilled is by first taking you have to check whether the p-value of fair statistic is less than 0.05, the r square is high, all the independent variable is significant, and then you check whether there is a multi-quality problem. Since that all the variable is less than 10, so there is no multi-quality problem, and you check the W Watson value whether it is less than or greater than 0.05. So since that the W Watson is greater than 0.05, there is no serial correlation problem. So, and lastly, you take a look at the whether the variant of the residual constant or uh, non-constant across time. And then based on this p-value, since the p-value is greater than 0.05, you have a constant variant across the time. So that's why we can conclude this model 7 is the best models, okay, based on this example data. Okay, and next you can try to forecast. Okay, since that you reach this as you can decide this is as your final model. Okay, try to forecast whether you get the value or not. Okay, but the thing that I want to highlight here is in your economic data. Okay, in your economic data, the number of car registration is in thousand. So means that this is actually 2160. Okay, in thousand. So means you have to times by thousand the value. So when you want to predict or you want to forecast this, okay, make sure that you use the uh, correct numbers lah. Okay, so for this, if you want to use this, you have to change it into 744.780, and then you try to focus by using that value. Okay, right. So that's I will leave at exercise and try to do the exercise uh, and share with me whether you successfully follow the step or not. Okay, I think I will stop here. Thank you for listening. Bye.